Chapter 1, I believe this is probably video 5 on structural formulas. I'm going to focus on structural formulas, condensed formulas, and then the line angle formula. So a structural formula, and I'll do probably all of them at the same time. The simplest one, this is methane. This is a structural formula. The condensed formula would just be CH4. Pretty simple. Oops, missed it. And after a while, you get tired of drawing all the hydrogen. This is ethane. It's condensed formula CH3, CH3. Just going to put my bonds here, then I'm going to come back and put the hydrogen in. This is propane. Its condensed formula is CH3, CH2, CH3. It also has a line formula, or a line angle formula. And that is just this right here. It is understood that this is a carbon, this is a carbon, and this is a carbon. Since carbon is supposed to have 4 bonds, this carbon is understood to have 3 hydrogen. This carbon has 2 bonds to 2 carbons, so it means it has 2 hydrogen. This one has a bond to 1 carbon, which means it has 3 hydrogen. Man, that is a lot handier to write. So this one here is butane. So it is CH3, CH2, CH2, CH3. You may also see it written as CH3, parentheses, CH2, 2 of them, CH3. Since there's 4 carbons, this would be example of the line angle structure. It is understood there's 1 bond showing, so it must be a CH3. This one here, there's 2 bonds showing, so it must be a CH2. This one here, there's 2 bonds showing, so it must be a CH2. This bond here, carbon has 1 bond showing, must be a CH3. So let's get into some functional groups. If we have an alcohol, let's pick on ethanol. And this is the formula for ethanol. The condensed would be CH3, CH2, OH. The lines, there would be this one here would be an OH. So it's understood that this carbon has one line to it. So it has to be CH3. It's understood that this one has two lines to it, so it must be a CH2. How about an aldehyde? Let's do propanol. So it's going to be a CH3, CH2, C. Now we can't write OH, but we have to write HO. Three carbons. We can put a double bond O here with an H. So going back, one carbon here, one line, CH3. Carbon here, two lines, CH2. Carbon here has a CH, and then there has to be double bond O because carbon always has to have four bonds. So if we have a ketone, oops, and I will pick on acetone. Or propanone as it's called. So it would look like CH3, CO, CH3. Its line structure, 3 carbon, double bond O. So what would happen if I give you just trying to make one up here as I'm going. So let's make sure all the carbon have 4 bonds. So how would we draw this in line structure without the hydrogen? Except for the functional group. This is a carboxylic acid. Six carbons make the ring. There's a double bond here, a double bond here. And that would be how you would make the line formula, line angle formula. Sometimes you may also see it written this way, which is acceptable. That is acceptable also for the carboxylic acid. Or you may combine the oxygen, CO2H. You're going to find out in this class I am going to draw a lot of line structures. And then you have to realize that, let me scroll down, that this is a CH3 bonded to a CH2, bonded to a CH2, bonded to a CH, and off of that CH is two CH3s. So when you see a line structure, a line angle structure, or the condensed form, you should be able to move them back between the different structures to help you in this class with tracking electrons. So if I had something like this, I'd realize I have a CH3. This carbon here already has 3 bonds, so it has to be a CH. Double bond C, going to a CH3, going to another CH3. So throughout this course, we're going to draw all kinds of structural formulas, condensed, and line angle formulas.